And all these domains can be basically divided into three basic categories of machine learning. The three basic categories of machine learning are supervised, unsupervised, and reinforcement learning. The basic difference between these three categories is that in supervised learning we have labeled data, right? So we know that what is the output of each instance present in the training data set, right? So but on the other hand, in unsupervised learning we don't have the labeled training data, right? We don't have any label associated with the training example or training instance. And in the reinforcement learning we basically take some feedback from the environment. On the basis of that feedback we basically determine the next action. So this is basically the three major or broader categories of machine learning. Now let's talk about a little bit about the technological aspects of the data science, like what are the tools, techniques, and technologies that are available which we can use in order to process data in data science. So the basic level or the first tier of this subset is the hardware resources, right? So normally which we usually use some graphical processing units which we call as GPUs instead of simple CPUs, right? Because where in GPU we can generate multiple threads, and each thread can be assigned for a specific task, right? It can be some simple pixel or matrix multiplication task. So it is way more faster. The GPU is much more faster as compared to simple CPUs, right? And nowadays we also have some TPUs, which are tensor processing units, which are being used in different machine learning and tasks. Now these GPUs are also being used in clusters and in clouds, and we also have some GPU farms where we can perform the machine learning algorithms on large data sets in on different distributed nodes. Also there are a number of programming tools available which help us to execute these machine learning algorithms. And the most prominent programming language which people are using nowadays is the Python programming language, but people are also using R and Scala, and also there are some other programming tools in Java which people are using in order to execute machine learning algorithms. Also, most importantly, since we have large amount of data, we are talking about big data here, and we are talking about massive amounts of data and complex algorithms, right? We are talking about deep neural networks here, which have millions of parameters and which have number of layers. So all these things requires memory as well as processing, because they are not only compute intensive, right? They are also resource intensive things. So it is not possible to handle all these challenges on a single system. So we usually require cloud computing infrastructures in order to process these things. And Microsoft is offering some cloud computing resources. We also have some IBM Watson available. So these platforms are cloud computing platforms, and people are using these to execute their algorithms. And also we need some frameworks, right? We need some cloud computing frameworks for the storage of the data as well as the processing of the data, right? And the most commonly used cloud computing frameworks are Hadoop framework and the Spark framework. Hadoop framework enable us to uh, to access the hardware resources for data storage and for data processing. On the other hand, Spark is also a variation of Hadoop, but it is way more faster than Hadoop, because Spark processes data within the memory, and it doesn't have the bottlenecks of IO processing, which are input and output bottlenecks, right? Because in Hadoop you are basically accessing and storing data again and again on your secondary storage, but in Spark we are doing most of the processing within the memory, and this makes Spark much more faster as compared to Hadoop, right? And also we have some SQL and NoSQL databases, and all these technological advancements enable us to process large amount of data with complex algorithms in the data science field. So here is the enterprise data platform. In this figure you can see that at the very bottom or at the very base we have different data sources. These data sources can be some structured data, this can be some unstructured data, right? It can be images, videos, numerical data, depending upon the application. And then at the upper level we have some data storage, and this data is which is being generated from these data sources is being stored in MySQL database or MongoDB database or Cassandra. So all these things are being used to handle and store the data which is being generated from different sources at this lower part, right? So here we can have some video cameras, we also can have some sensors which are being generating data with high scale and high velocity, right? So after this data storage layer we have big data platform, and if you can see in this big data platform we have a underlying Hadoop architecture. So we use HDFS file system here in order to store the files, and then we also have Yarn and Spark clusters, right? So Yarn is basically a cluster resource manager which helps us to manage the resources of the cluster, and in order to process the data within the memory and in order to have fast execution of the operations we employ Spark on top of that. And this basically this platform, this big data platform, can be handled or can be accessed by a number of libraries and algorithms. So normally we use languages such as Python, R, MATLAB and Java, and there are a number of libraries which have been built in these languages such as NumPy, SciPy, Pandas, Scikit-learn, TensorFlow. So these are a number of libraries, and these libraries have implementations of a number of algorithms, a number of machine learning and deep learning algorithms, and those algorithms are k nearest neighbors, support vector machines, neural networks, decision trees. And if we are talking about deep learning algorithms, then there are many deep learning algorithms which we are basically using in order to process and execute the data science applications.